Hello and welcome. uh, how we doing? How we doing? What's up, Trinity? Trinity, Johnny, Tyler, Cooper, Valen. Hey, Valen's got the emotes. This is Roman numeral 2. It's continuing on from the notes we were working on. Spring break is next week, Weaver. We're not on spring break yet. No, we just did Roman numeral 1. No, I looked at the YouTube video. It was just 1. Because we had Roman numeral 1, it was the 5 types of reactions. And we... Oh. Okay, then this is 3. I must have misread. Thanks, Hunter. Yeah, do you like how I changed that 2 into a 3? Skills. Sorry, Cooper. I needed a second witness. But now that I've got one, we're good. Cooper's mad that I didn't believe him, and I believed you, Hunter. Okay. Sweet. So hopefully everybody got the worksheet done last night. Oh my gosh, Val's just gonna keep spamming my pog emote. Hi Drake, glad you're here. Let's see. A couple people missed it, but they're the people that miss everything. So make sure if you didn't finish the word equations worksheet last night, that you get it done as soon as possible. Yeah, Sonaris is back. Hey, Sonaris. And I should make it cost more valence electrons. I was wondering that the other day. I don't actually know why they use S. I mean, you can do a quick Google. It's because Clausius used it. Oh, I guess in honor of the French physicist Nicolas Sadi-Carnot. So I guess Clausius did it as a nod to Sadi-Carnot. I don't know. Somebody decided to use S, and so it stuck. Yeah, I have other emotes coming, but we're still waiting on them to get approved. I've submitted them to Twitch, but Twitch has to approve your emote to make sure it's not inappropriate. I know. I would never be inappropriate. But the emotes have to look at it. Yeah, that's real. I think they did. I think actually Drake's not in my class, so Weaver would have to check on Drake. But Valen got it done. Yeah, Valen did okay on it. He probably should have redid it. Did you look up Sadie Carno? Sorry for the shots fired. Pow, pow. Speaking of people that didn't do it, Kai, you didn't do it. Make sure to do it. Do it tonight. It's still open. It'll mark it as late. MyOMO. Yeah, I was thinking about doing I do have a what emote, but it's not Professor Quantum. It's just it's that same little me as the anime character. Oh, Weaver's posting him to Skyward. No, I didn't look at folded. I'm gonna make myself a note right now, Sonars, so I remember. No, Hunter, nothing's due over spring break. You could have gotten help, email, Discord, um, all those things that, I have available for you to get help on and help with. But you didn't use any of them. So I don't feel bad. I don't know about that one, Valen. We'll have to see. Good job, Johnny. Yeah, Weaver's very excited about spring break. I'm not going to watch it on stream. I'll watch it later. You're getting a spring break, Cooper? You just can't go anywhere. It's spring break in your home. Yeah, more sitting around. Yay. Yep, Xander, that's how Twitch works. All right, so let's get into the notes. Yeah, you gotta spend 10,000 valence electrons. Yeah, you can go hiking. You just have to make sure you avoid any and all people. Well, and I guess depending on the regulations of where you currently are, but yeah, I actually don't mind it all that much because a lot of my interactions is with people online anyway. Drake, if your computer's struggling, you can always watch the YouTube video later. You just won't get any active help. So, well, I mean, if you live with somebody, you can maybe get whoever's in your home could maybe go with you. All right, let's go into it. Yeah, no, you can't ski. The ski resorts are all closed. So today we're going to talk about total and net ionic equations. This is kind of builds off of the word equations we talked about last time. Oh my gosh, Cooper, stop calculating the number of dabs I can do per minute. All right, so let's get into this idea. So if we remember, we have to understand. We have to review splitting. So I'm going to say review splitting. So we talked about two different kinds of compounds that split when they are aqueous. So what kind of compounds did we say broke apart into ions when we formed aqueous solutions? Do you remember? So, ionic liquids conduct electricity, but ionic as aqueous do, they split as aqueous. So we have ionic that split, and then we have one other one. Strong acids, good calling, yeah. Okay, as a reminder, right, the strong acids were HCl, HBr, HI, HClO3, HClO4, HNO3, and H2SO4. Okay. Oh my gosh. Can we refrain from talking about death in the chat? I would appreciate it. All right. You only get it for 24 hours, Valen. Sorry. Or Valen. So you'll have to reuse your valence electrons on it next week. Or I guess in a week and a half. So I'm going to up the price then. So, so we got to remember that everything else stays together. I'm still not going to watch it on stream. All right, so it stays together, everything else. So the only thing we need to worry about splitting are ionic and strong acids. Okay. So yeah, let's talk. I guess the best way to do it is to get into what it is, right? So we'll do. Really, I'm just going to call these examples. Okay. So yeah. Oh, did I say something wrong, Weaver? Did I catch myself up? No, you're good, Drake. Hopefully, try to get better internet. Maybe hardwire into your modem if that's an option. If you get an actual Ethernet cord, that'll help your lag. Yeah, so ionic and strong acids completely split apart. Everything else stays together for the most part. Wired Wi-Fi. That's not a thing. Okay, so let's go through some examples. So I went ahead and wrote out a couple other ones. So I'm going to do, let's do this one first. So we'll call this one number 1. So here's number 1. It says hypochlorous acid mixes with a solution of calcium hydroxide to produce water and what aqueous? I don't have music set up to play, Johnny. Sorry. So over spring break, I'm gonna look into revamping the stream a little bit, getting some higher production quality, and maybe add some background lo-fi or something to keep you guys entertained, keep you listening. But nothing right now. Nothing for today, Johnny. Sorry. All right, so hypochlorous acid mixes with a solution of calcium hydroxide to produce water and what aqueous. So this is kind of a big problem, right? There's a lot here. So let's just dive into it and kind of start simple. Okay. And yeah, so Tyler has a point. If you want some music, you can always open another tab. Yeah. Here you go, Val. Ainsley, I'm hopeful that we'll go back in May, but that just kind of really depends on how April goes. All right, so let's write it out. So first thing we notice, we have hypochlorous acid. So hypoous comes from chlorite. Chlorite is ClO minus. So hypochlorous acid is going to be HClO. Now, so chlorous acid is HClO2, Cooper. Hypochlorous acid is just HClO. Because chlorate is ClO3. So chlorate ClO3, chlorite ClO2, hypochlorite is ClO. So hypochlorous acid is going to be HClO. All right, so hypochlorous acid. For these problems and for the worksheet that you have, the homework you have, acids you can always assume are going to be in solution. So acids are always going to be aqueous. So it might not say that they're aqueous, but we can assume the state. So the state is actually going to become really important for these problems. So it didn't really matter on the word equations worksheet that was due last night, but for these problems, the state is huge because we have to know if something splits, and whether or not it splits is dependent on the state. So state is going to be really important. Make sure to include the phases on all these things. Okay, so hypochlorous acid mixes with a solution. So if mixes with a solution, we're going to put a plus. Okay, and then we have calcium hydroxide. So CaOH, calcium hydroxide. But we need to remember calcium, right? If we take a gander at our periodic table, calcium is in the second column, so it forms a +2, right? And hydroxide is a -1, so we need a 2 here. We've got a couple questions. No homework over spring break, right? Okay, so that's the calendar. This homework's going to be due 2 weeks from yesterday. Precious. Ionic acids, no ionic acids. All right, so it says it mixes with a solution of calcium hydroxide. If it's in solution, that means it's aqueous. Okay, so hypochlorous acid mixes with a solution of calcium hydroxide to produce arrow. What is usually AP? I don't understand the question, Jonathan. This is a Q for aqueous. A Q. So acids are usually aqueous. Acids are aqueous. You want to balance the charges of acids, right? Because they're not ionic. No, you still want to balance. So you still want to add the proper number of hydrogens. None of your classes should be giving you new homework over spring break. All right, so we produce water, which we know water, H2O, liquid. And then it says, and what aqueous? Okay, well, wait a minute. You do add the hard charges. You add hydrogens to balance the charge. Yeah. So because hypochlorite's a -1, that's why we only need 1 hydrogen. If we're doing like sulfuric acid, sulfate is a -2, and we would need 2 hydrogens. Phosphate is a -3, and so we need 3 hydrogens to make phosphoric acid. Okay, so hypochlorous acid mixes with a solution of calcium hydroxide to produce water and what? All right, now but it doesn't matter, Johnny. I guess it does matter for state, but yeah, we're assuming that they are occurring at room temperature. Okay. So the question is, right, where did this water come from? That might help us predict what this other product is. Okay, so if we look at, and we think about the reactions that we did, no, aqueous water can't be aqueous, Matthew. Good question. So K is already predicting calcium chloride, not calcium chloride, calcium hypochlorite, right? So because we know the water comes from the hydrogen and the hydroxide, right? If hydrogen reacts with hydroxide, that gives us water. HOH is just H2O. And so we're doing a double replacement reaction. And so the hydrogen and the calcium are swapping. And so the other compound is going to be calcium hypochlorite. So CaClO. But to balance the charges, hypochlorite's a -1 and calcium's a +2, so I need a 2 there. And then I'm running out of room, but that should be aqueous. Because water doesn't dissolve in water. Water is water. So yeah, Anya, technically there is water here, but the water that's dissolving these compounds is not directly involved in the reaction. And so just because something's aqueous doesn't mean you have to include water. No, aqueous and liquid are two very different things. Liquid is the liquid state. Aqueous is dissolved in water. Liquid salt is if you take salt and heat it up to like 800 degrees Celsius. We're not done yet, Cooper. I've got too many other questions I'm trying to answer. People aren't letting me actually finish the problem. So aqueous and liquid are not the same thing. Aqueous salt is when you just mix salt and water. Liquid salt is when you raise it up to 1,000 degrees. Yes, it is important that water is involved, but it's not reacting. So you puta. Careful how you spell puta. That's a Spanish swear word. Okay, so can you dissolve water in another liquid? Yeah, technically, Faye. So you can actually dissolve water into alcohol, and you can make like an alcohol solution. But for our class and for our purpose, this is just an intro level chemistry course. We are just going to stick with any kind of solution that we're going to make is going to be aqueous. Okay. So let's balance the equation, right? So I see there's 2 hypochlorites over here. So I know I need a 2 in front of the hypochlorous acid since Spain. All right. So, and then now if we look at the hydrogens, I have 1, 2, 3, 4 hydrogens on the left. And so I need a 2 in front of the water. And then I think it should be balanced then. 1 calcium, 2 oxygens, 2 oxygens, 2 hypochlorites, 2 hypochlorites. Okay, so we're balanced. I mean, yeah, kind of, Hunter, but there's more technicalities to it than that, so don't stress about it. Okay, so back to this equation. So this right now, this is what we would call a balanced chemical equation, or just the balanced equation. Okay, what we're going to do now is we're going to look at the total ionic equation. Okay, so when we talk about a total ionic, what we're going to do is we're going to take any compounds that split, and we're going to write them as being split rather than as being stayed together. Tyler already answered that question. I said, yeah, technically, but it's more complicated than that, and I don't want to get into it. Okay, so total ionic. So we have to ask ourselves, when we look at each of these 4 things, do they split when they dissolved? When they dissolve. Does hypochlorous acid split? If it's an acid, right, there are some acids that split. Is hypochlorous a strong acid? Nope. It's not a strong acid, right? It's close to chloric acid or perchloric acid, but it's the wrong number of oxygens, and so it does not split, it stays together. Dylan, side note, the worksheet that was due last night, get it turned in. All right, so it's going to stay together. So we're just going to rewrite it exactly as is. Yeah, turn it on a canvas. All right, now then the calcium hydroxide. Okay, does calcium hydroxide split? Yeah, it's an ionic compound, metal, nonmetal, and it's aqueous. So aqueous ionic do split. So we're going to rewrite that split. Now you got to be careful when you split it because it's going to split into calcium ions, Ca2 plus, and the 2 for the hydroxide comes in front. So it's 2 hydroxide ions. Now I'm going to give myself a little more space. I'm going to move this down. So water, right? Water's a liquid. Water's a liquid, stays together, it's a liquid, right? The only things that split are aqueous ionic and aqueous strong acids. So because water's a liquid, we're going to rewrite it, just stayed together. We're going to rewrite it as 2 H2O liquid. Okay. What about calcium hypochlorite? Does calcium hypochlorite split? Again, it's aqueous ionic, so yeah, it's going to split into calcium ions, Ca2 plus, and hypochlorite ions, 2 ClO minus. Man, I still ran out of room. Ugh. All right, so here's our equation. Notice, right, so this is the total ionic equation. The total ionic equation is basically the same thing as our molecular or our overall equation. All right, good, Meredith. Meredith's anticipating where we're going. So yeah, for the net ionic equation, we're going to remove what are called spectators. So a spectator is something that stays the exact same on both sides. It has to be the same formula, the same charge, and the same phase, right? So if we look at this, we have HClO, and then over here we have ClO minus. Those are not the same, so those cannot be removed. But the calcium ions, right, Ca2 plus aqueous, Ca2 plus aqueous. Because it's the same on both sides, that means it's not actually reacting. It's just chilling, right? And so as a result, we can eliminate it so we can focus on what's actually happening in the reaction, and we can say, all right, whatever, calcium, forget you. The hydroxide changes into the water, and so the only thing that changes is my calcium. So I'm going to rewrite it with the calcium removed. Yeah, so technically, Cooper, no, Cooper, if the numbers change, it technically still is a spectator. So if I had like 2 calciums here, and I had 1 calcium there, and then I had another calcium in like a compound, you actually can eliminate one of the calciums and have 1 left over. So like you can have half of them being spectators and half of them actually reacting. And I have an example that will do that. So hold off on that question. That's a more kind of complicated nuance. So yeah, we'll get into that. We'll get into that, Zach. Don't worry about it. Let's focus on this problem. So in this problem, right, we eliminate the calcium because the calcium stays the same on both sides of the equation, calcium 2 plus. Everything else stays. We can't eliminate anything else because they're all changing as we do the reaction. And so when we go to the net ionic equation, we remove any of the ions, the spectators, that are not directly involved in the equation. And so this is our overall. Another thing you can do is technically, because this is 2, 2, 2, 2, the coefficients are all 2s, we can kind of get rid of the 2s. And if we wanted, we could just rewrite it kind of in a simplified form. But that's optional. You don't have to do that step. I'm glad your ducks are enjoying the stream. Okay, questions on this problem. We're going to do 2 or 3 more examples if we can. You always write hydroxide. So that's because they're charged. They're ions. So when we split them, so up in this first equation, nothing should have a charge. Everything should be balanced. But when we split them, right? When we split the calcium and we split the calcium hydroxide and we split the calcium hypochlorite, we split them into their charges. And then we get rid of calcium because it's the same on both sides. Okay? Because, so just like in sports, right? A spectator doesn't actually play the game. A spectator just sits and watches. And so in this case, our calcium ions are not actually involved in the reaction. And so they're just kind of sitting and watching. Yeah, and this is a good call, Tyler. This is a double replacement reaction. Okay, let's do another one. I'm going to move on. Everybody good on this problem before we're going to do more examples, and hopefully that'll clear up some confusion. All right, let's do some more examples. Number 2. So number 2 says, ammonia gas is bubbled through a hydrochloric acid solution to produce aqueous ammonium chloride. Okay. So let's start with the equation. Ammonia gas. Right? We should have memorized ammonia is NH3. Okay. So it's bubbled through. So that's another way to say it reacts with. Right? So ammonia gas is bubbled through, reacts with hydrochloric acid. Now, hydroic, hydro, right? That tells us it comes from chloride. And so hydrochloric acid is going to be HCl. Okay, aqueous, right? Hydrochloric acid solution, acids are going to be aqueous, to produce ammonium chloride. How did I get a 2? Tyler, what are you talking about? Oh, this is problem number 2. Because this last one was problem number 1. And then it says produce aqueous ammonium chloride. Ammonium NH4 plus, chloride Cl minus. Okay, so first thing, right, we've got all the formulas correct and we have all the phases. Now we want to see if the equation is balanced. 1 nitrogen, 3, 4 hydrogens, 1 chloride, 1 chloride. Okay, so this one's already balanced. So that was easy. Okay. So it's already balanced. That's nice. So now when we go to the total ionic, right, we need to split any aqueous ionic compounds or aqueous strong acids. So ammonia, that's a gas. That's not aqueous ionic. That's not a strong acid. And so we just rewrite it exactly as is. Hydrochloric acid. Yeah, I don't know, Serenius. I don't know what your viewing history recommended this stream to you. I just means you write it like it's the element. Yeah, chloride is just the element. No, good call, Lauren, on that one. Stonks. Yeah, if this had said chlorate, then it would be ClO3, right? But because it says chloride, it's the element chlorine with a negative charge. All right, hydrochloric acid. Do we split hydrochloric acid? Yes, because it's a strong acid. So because it's a strong acid, it's going to split into H plus and Cl minus. Okay. Ammonium chloride. Does ammonium chloride split? Ammonium's a little tricky. Even though ammonium isn't a metal, ammonium still forms ionic compounds. And so ammonium chloride is technically an ionic compound. And so because ammonium chloride is an ionic compound, it actually does split into the ammonium ion and the chloride ion. Yeah, we'll do a couple more of those, and yeah, we'll do another problem that has like a missing part of the equation. All right, so Lauren's really excited. We are going to remove the chloride. Good. Lauren Ainsley got it. Easy peasy. So because the chloride is the same on both sides, we are going to eliminate it, and it is considered a spectator. And so when we go to the net ionic equation, we're going to rewrite it with the chloride missing. And so we should have NH3 gas plus H plus aqueous makes NH4 aqueous. Ain't delicious? Nothing wrong with that. Good. Yeah, so good call, Cooper. So Cooper's wondering, why is this hydrogen, and technically chlorine too, why are these not diatomic? Shouldn't they be H2 and Cl2? I thought whenever we had hydrogen and chlorine by themselves, they were diatomic. So the reason why they're not diatomic here is because this is hydrogen ion, not hydrogen gas. Yes, you did, Serenius. This is chloride ions, not chlorine gas. Okay? Yeah, they're not by themselves, they're ions. I mean, you're welcome to stick around and learn, man. So, yep. That's why they're not twos. I think that hopefully that answered your question. Okay, this one was a little simple. I probably should have started with this one. Let's do... I love how you guys are mocking each other's names. All right. Cool. Questions on this one? This one was a little more straightforward. We'll do a more complicated one. Yeah, we'll do this one. Okay, number 3. Okay, so number 3 says solid copper reacts violently with nitric acid to produce water, a solution of copper 1 nitrate, and nitrogen dioxide gas. Hey, food science is cool. All right, so let's start with our molecular equation. Okay, so let's come up with a balanced chemical equation. So solid copper. What do we do about solid copper? Yeah, violently. Sorry, violently. My eye kind of got crazy. So solid copper. So we're going to start with Cu, solid. Right? Solid copper. Reacts violently. So plus nitric acid. Here we have ic acid. Ic acid. Nitric, right? Nitric comes from nitrate, and so it's going to be HNO3. Nitrate is the nitrate ion, NO3 minus, so we have H plus to balance it. So nitric acid, HNO3, and we said that acids are going to be aqueous, right? So copper solid plus nitric acid. So copper solid copper reacts violently with nitric acid to produce arrow. Oh, I got an email. Oh, nothing important. No. All right. A solution of copper 1 nitrate. So to produce a solution of copper 1 nitrate, so CuNO3, right? Remember, the Roman numeral 1 tells you the charge of the copper here. So this copper is a 1 plus paired with the 1 minus, right? Makes it so it's already balanced, CuNO3. So it says a solution, so that means we know it's aqueous, a solution of copper 1 nitrate. Oh shoot, I forgot the water. Whoops. To produce water, I'll write it second. It's fine. It doesn't matter what order you write things in. To produce water, a solution of copper 1 nitrate, and nitrogen dioxide gas, NO2 gas. So remember, this is a molecule, so nitrogen dioxide, NO2. Okay, everyone's like, what about the water? What about the water? It's there, it's fine. Okay, so nitrogen dioxide, you don't have to worry about charges. You just follow the equation NO2. Sorry, that's an L for liquid. It's just kind of more of a cursive L, so that it's distinguished between this Roman numeral 1 and then an L to say liquid. Okay, so now we need to balance the equation. So one copper, right? One hydrogen, two hydrogens. So we know we need a 2 in front here. Let's see, that makes 2 nitrogens. We have 1 nitrogen, 2 nitrogens, 6 oxygens, 3, 4, 5, 6. Okay, so we're good. Yep. All right. So now, so if it doesn't say what state it is in, we're assuming it's a state at room temperature. Yeah, Lauren, yeah. We're assuming all these reactions happen at room temperature unless specified otherwise in the equation. And if I didn't want it to be water as a liquid, I would probably call it steam or ice. Because if I said steam, that would be water as a gas. And if I said ice, that would be water as a solid. All right, so let's take this equation and go to our total ionic. Okay, so remember we're looking for aqueous ionic and aqueous strong acids. So copper solid, that doesn't fit the bill, so we're just going to rewrite that copper solid. Nitric acid, let's see, it's an acid. Is that a strong acid? Yep, so it splits. Now you got to be careful when you use a coefficient and you split something. That coefficient has to go to both of the ions. And so when we split this, we're going to get 2H plus aqueous and 2 NO3 minus aqueous. So don't forget that that 2 applies to both. Okay, produces copper nitrate, that's a metal with a non-metal, that's ionic, that's aqueous. And so we got to put copper ions, Cu plus aqueous, nitrate ions, NO3 minus aqueous, plus water, right? That doesn't split. And then NO2 is a gas, so it doesn't split either. Yeah, so copper nitrate splits. No, you're good, Zach. It's good that you're anticipating it. Okay, so there's a whole lot here, right? Are there any spectator ions? There isn't a 2 in front of NO2. Anya? Remember, there's nitrogen here, and so that balances. Ah, copper is a trap. No, the copper does not get eliminated because we have copper solid and we have copper ions. Those are two very different things. That one electron makes it so it's having a reaction. There is a difference between copper solid and copper ions. Those are not the same. Those do not cancel. Because I'm trying to teach you, Ainsley. I'm trying to let you learn you. Right, now the nitrates, on the other hand, this I was mentioning this earlier. What can happen is with these two nitrate ions, one of them stays the same and one of them turns into NO2. And so we get rid of one of the NO3s, right? So we can rewrite the equation. So this is our net ionic. So we rewrite it as copper solid plus the 2H plus. Okay, we get rid of this 2 because we're going to get rid of one of the nitrate ions. Okay, that makes copper ions. This nitrate goes away. Okay. The only time it would cancel out the copper, Jonathan, is if this was like copper plus on this side and we had copper plus on that side. So if they were the same charge, same phase. Okay, so what you want to check sometimes is you could have made a mistake somewhere along the line, but in every line, your equation should remain balanced. So to make sure we didn't screw this up, one copper, two hydrogens, one nitrogen, three oxygens, 1, 2, 3 oxygens. And so it's still balanced. And so we thankfully didn't screw it up. Okay. So this one is probably one of the more complicated problems, but it's a good example. Hey man, thanks for tuning in. Have a good day at work. I guess you work in a restaurant probably if you gotta keep going to work. So thanks for keep working. All right. Any questions on this one? I can English, Zach. It's fine. It's fine. I can English. I English good, but gooder than most. Just like Grandma used to make. I love me some synonyms. Okay, so there's obviously not any questions on this since we've divulged. I speak English the most bestest. That broke me when you English bad. I sorry English bad. Okay. Cool. Let's do I have one more practice problem. What I'm going to do on this one, I'm going to give you guys like 3 or 4 minutes. See how far you can get on this one. If you've got like a piece of paper handy, go ahead and grab it. Thanks for follow, Jackie Shea, or Jackie's Hay, probably Jackie Shea. So I only know 7 compounds split, and copper nitrate is. So nitric acid is a strong acid, right? So remember we have 7 strong. So those are the strong acids. Any other times ionic compounds will stay together. So ide is an ick in an acid, right? No, ide is hydroic, Enya. So sulfuric acid here is going to be H2SO4. Because ick comes from 8. So we have sulfate. So hydrogens, so sulfate's SO4 2 minus, and so to make sulfuric acid, we add 2 hydrogens. There's a homework assignment. So ide comes from an element. 8 is the normal polyatomic ion. Ite is the polyatomic ion with 1 less oxygen. That's all on the naming reference sheet, which is here. So if you haven't taken a chance to review that, you probably should. All right, here's the equation. Is it balanced? I don't actually know. 2 hydrogens, 1 sulfate, 1 calcium, 1 carbon, 3. Yeah, it's already balanced. Oh, that's cool. So our coefficients are just 1, 1, 1, 1, 1, 1, 1, 1, 1. So for the net ionic equation, or sorry, the total ionic equation, we have to break apart any strong acids or aqueous, okay? Or aqueous strong acids or aqueous ionic. So strong acid, sulfuric acid is a strong acid. And so when sulfuric acid splits, it splits into 2H plus and sulfate. All right, now be careful on calcium carbonate. Because it is a solid, solids do not split. Ionic compounds, if they're solid, don't split. They stay together. And so we're just going to rewrite it as calcium carbonate. Water being a liquid is going to stay together. Carbon dioxide being a gas is going to stay together. And calcium sulfate is also a solid, and so it's going to stay together. So in this case, Zach, there are no spectator ions. And so the net ionic is the same as the total ionic. The only thing that split was the sulfuric acid. So I wanted to do this one as a last example to say that sometimes there are no spectator ions, and the net is the same as the total. Because apparently everything is involved in the reaction in some fashion. So the assignment is due 2 weeks from yesterday. So we're not going to have anything next week because of spring break. And so the assignment is due on Thursday the 16th. So how can we assume the solidity of calcium carbonate? And I just saw it was solid. Okay, yeah, so the assignment's due 2 weeks from yesterday. If you want to work on it over the break, you can, but know that I'm not going to be checking Discord as regularly. I'm not going to be checking my emails regularly because it's a break for me too. Yeah, you're good, Zach. Okay, we are at 9:25, and so we're done with the notes. We're done with the practice. If you want to start into this worksheet and get some help with it today, you can. Oh, sorry, that says no spectators, Sonaris. Sorry, that's an N. No, Valen. I have to get ready for AP. Weaver is back with the excitement of spring break. I technically the Brighton Esports team does have a couple scrims that they're going to be playing next week, so I'll be streaming those if you want to get your daily dose of Gillespie stream on Monday and Tuesday. And then I do have my BYU class that I'll be teaching my college class still on Tuesday and Thursday nights. So Weaver has his grades updated. If there's any last final questions, they play League of Legends, Dylan. They play League of Legends. No, the company we're using isn't doing Fortnite this year. They're maybe doing Fortnite next year. So we might have a Fortnite team next year. I mean, yeah, and if you want to watch it, if you're obnoxious during the BYU stream, I'll just kick you out. But we're doing organic chemistry, so you can learn about some OChem stuff next year. It's the same level as AP. Unfortunately, with COD, it's mature rated, and so getting mature rated games approved for high school is a very difficult thing to do, Dylan. It'd be cool to have a COD team or a Rainbow Six team or something, but mature games are a lot harder to get approval on. All right. I am going to go ahead and close out the stream. Yeah, Madden or like FIFA would be interesting, but there's not enough of a big thing for that. Whoa, chat just exploded. You only split strong acids and aqueous ionic. Yes, Jonathan. We are definitely going back to school next year. Okay. Have a good rest of the day, guys. Enjoy your spring break next week.